Okay, now we're broadcasting live, and my name is Ted Ritzer. I'm the host of the Greening Government Speaker Series, and today we're fortunate we have an expert on carbon busting, not just one generation, but a second generation carbon buster, Godo Stoyke. And Godo is in the process of getting his PhD. And he's got a third generation carbon buster, a son that who knows whether he'll enter the carbon busting fold. But Godo, this is just so wonderful that you've been able to join us here. And I'll turn it over to you, Godo. You're the main event. Can't wait to hear more.
Great, thank you very much. Well, first of all, I'd like to thank Alberta Environment and Parks and the MCCAC for putting on this great series. And also, I'd like to especially thank Ted Ritzer personally, because he's been putting a lot of time and effort into this to make this happen. So thanks, Ted. It's appreciated. My name is Godo. If you have read Samuel Beckett's famous play, you may be familiar with the pronunciation. And in case you're wondering about the accent, I was actually born in Edmonton, so it's an Edmontonian accent. And if you don't buy that, I have to admit that I did grow up near Hamburg in northern Germany. Also, I don't eat any meat, so to say I think that I'm the original vegetarian hamburger. Anyway, today we'll talk about carbon busting for fun and profit, and might as well step right in. Okay. There we go. Well, I'll start with a little anecdote, actually. One of my friends had a visitor from Japan, and this visitor was really impressed by Alberta's leadership and Canada's leadership in climate change and the environment. So this friend asked him, well, why do you think we are such great leaders? And he said, well, look at your parking lots. Every parking lot has a plug-in for electric cars. Carbon Busters, I'll tell you a little bit about our company. It was formed in 1992. We have worked with municipalities and school boards in North America and Europe to in approximately 129,000 students to basically advance climate change education, and at the same time save energy in those municipal buildings and school board buildings. Recently we're also moving more into a zero carbon building design. This is a garage suite we're building right now in West Edmonton that has a zero carbon and net zero target. And I'm also the co-founder of a second company that is a non-profit company that was launched with the assistance of the City of Edmonton and the Social Enterprise Fund. Is called C Returns. Basically, you want to see returns for cash carbon community. And this company specializes in retrofitting existing buildings. So, for example, institutional, commercial, and residential buildings. And we, for example, retrofit a number of the community leagues in Edmonton under this program. And altogether, these two companies so far have saved about 81 million kilograms of CO2 from being emitted to the environment. And Carbon Busters alone has created utility savings of about $26 million in the buildings that we've worked with. And as Ted mentioned, I'm also currently I'm a PhD candidate at the University of Calgary, Faculty of Environmental Design, and my topic is basically optimizing zero carbon. Let me turn this off here. I should have reminded everybody to turn off their cell phones. Happens. Whoa, there we go. So zero carbon building design. Basically, I'm looking at life cycle assessment of the building from an economic an environmental perspective, energy efficiency, as well as carbon emissions. And I'm focusing in on making or integrating high-performance buildings better into a 100% renewable provincial electricity grid that we are hoping to build in the future. And particularly, I'm looking at short-term thermal storage that allows you to basically avoid peaks in the Alberta grid. And also, once we have a dynamic pricing system where basically you get rewarded for using off-peak hours, so at night, for example, like California right now has a system in some municipalities where you pay as much as 27 cents during the day. For one thing, you can see they have a lot higher energy prices, but at night you pay only 10 cents. So, and they have special rates also for people who have an electric car. So they want these people to charge their car at night when there's excess capacity usually, and they pay slightly higher rate at during the daytime, but get a discount rate at night. So it's related to that kind of concept. You're basically wanting to support the grid in reducing peaks, at the same time also supporting the integration of renewables, because as you know, many of them are non-dispatchable. That is, like, we can't determine when the sun shines or when the wind blows. So if you have a building that is responsive to the current energy supply, then you can basically help this grid become more renewable. I've also written a number of books on the topic. Basically, all these books are on the theme of how to fight climate change, either in this case on the residential level or in this case on the municipal level. And another book is about making schools greener. In terms of personal history, I've lived in an off-grid solar-powered home for 21 years. And this is a picture out that window. You can see some interspecies communication here. And that was in 1990 when we moved in there. And at that time, our solar system cost $14 per watt. So comparison 2015, right now, it's about 89 cents per watt. That is just for the module, that's without installation. So you can see a dramatic drop in price. One of the other benefits of living out in the country was we got a monthly free car wash by this friendly moose that dropped by. Actually, what it was really trying to do is lick off the salt, the road salt from the car, but was a fringe benefit, I guess. Okay, let me just move this one window here a little bit. So I often ask participants in a presentation, what do you think are the top green energy sources in Canada? And often people think of items like solar energy and wind. And I would agree that those are the top renewable energy sources, but not necessarily the top green energy sources. And we basically believe that the top green energy source are actually megawatts. Megawatts are the watts that you don't consume. It's basically the path not traveled. Now, if you think about it, we really are looking at getting services from the grid, for example, the electrical grid. We want a hot shower and a cold beer and a hot coffee, not necessarily in that order. And we don't really care how many kilowatt hours we take. Right now, typical building, a new building might use 30,000 kilowatt hours for heating and maybe 8,000 kilowatt hours for electricity. And we don't really insist on having this consumption, we just insist on getting good services. So megawatts basically answers the question, how can we achieve the same service with fewer resources? And that can apply both to energy and to materials as well. So, and then I often ask people, well, what do you think is the second best source of green energy in Canada? And well, we think it's also megawatts. And in fact, as much as 75% of our energy can be saved through efficiency. And that's already happening. If you look at the patterns in North America, the patterns in Europe and in Japan, you will find that we are wringing more and more productivity out of each unit of energy. This graph kind of shows is a cost curve of the various energy potential savings for electricity. And with the average cost, in many cases, being far lower than the cost of the grid-supplied electricity. And in fact, the Rockman Institute in Colorado is probably the world leader in efficiency thinking. It's kind of an efficiency think and do tank, as they call themselves. And you can see here on this graph that if we pursue the opportunities for efficiency, we can save the vast majority of energy can be saved by 2050. So this graph, the green part of the bar shows what's already happening, business as usual. So just from people taking initiative and businesses investing in efficiency for their business. But if we actually accelerate this process, we could save an additional 53% of our total energy consumption in North America through efficiency. And that makes it so much easier to meet the remaining energy needs through renewables. And an interesting thing, of course, for Alberta, 80% of our carbon emissions actually are based on energy. So that is definitely the point where you want to start. It's not the only one, but the most important one. This is just the cover of the book. And you can actually get a very similar book called Winning the Oil Endgame, which is also written by Amory Lovins, but which is available online free of charge. Just type in Winning the Oil Endgame PDF, and you can download it for free. It's entirely legal. Or if you want a slightly updated version, that is, again, Reinventing Fire. So altogether, we can save approximately $370 billion per year if we basically take advantage of these savings opportunities. And I'll start maybe with a few examples from the building sector. And this is on the top left, one of the first net zero homes in Alberta in Riverdale in Edmonton. On the right-hand side, you see the Mill Creek home in Edmonton, but actually Alberta is actually a leader in net zero buildings across Canada. We also have a number of net zero buildings in Red Deer and in Calgary. So we can be proud of our accomplishment in that area. And there are also opportunities to take advantage of in the commercial building field. This one is the Greenstone building that I visited in the Northwest Territories in Whitecourt. And in this case, the design basically incorporated savings opportunities right at the design phase. So for example, all of these, many of these windows have integrated solar. But what's more important is that these are high-performance windows that were built at the time by Vision Wall, a former company in Edmonton. And these windows have an R value of R7. That compares to about R2 for a typical double-pane window. So it's about 3 times as good. Now, the cost of these windows was about $300,000 extra. So the incremental cost, it raised the cost of the window systems from $2.8 million to $3.1 million. But because they are more than 3 times as efficient as a regular building, the designers could also downsize the mechanical system. And in fact, the mechanical system went down in cost by $800,000. So you have a building that not only costs less money to build, but that now has 3 times lower losses in the winter in terms of heat losses, and also is 3 times easier to cool in the summer. So in the residential frame, it's a lot harder to hide the extra costs of your green systems, because all you have is a $7,000 roughly furnace. Well, and that's also the hot water tank, I guess. But it's not a very high cost. In the commercial field, the mechanical systems tend to be a lot more expensive, and there it's a lot easier to offset the green costs with other capital costs for mechanical systems. And another thing that we are excited about is the rise of something called the passive house. And passive houses this is a design standard that was developed in Sweden and Germany, and that allows you to cut the consumption of a house by about 90%. And this is achieved by basically looking at primarily the building envelope. So, I mean, you can add, later on, you can add photovoltaic systems, and you can add all kinds of extra embellishments. But the interesting thing is that once you build a house, it is very hard to change a building envelope. For example, if you have a lot of air leakage, which is still the case in most new buildings, they have very high losses from that. If you have poor walls and windows, those are all things that are relatively costly to retrofit, but are a lot cheaper to implement when you do it in the design phase. And this is an example. This actually is, though, a retrofit of a passive house, and you can see the thermal images at the bottom of the screen. The bottom left is the original phase, and so the lighter the color, the more heat loss. You can see the blazing heat loss in some areas where it is around here. You can see the white areas, so those are windows. But even lots of the walls and part under the eaves, you have a lot of heat loss. And you can see by comparison, the color of the cars, they have pretty much dropped in temperature to the environmental temperature, so it's blue. Huge difference. And then on the right-hand side, at the bottom, you can see the picture after the retrofit. And the building has an amazing building envelope. And the windows have been vastly improved. And even though they have the highest heat loss, most of the windows have less of heat loss that you had before, just from the walls. And interesting thing, if you look at the cost and benefit, this graph shows the incremental cost of making the building go green, and how this is only at scale. So new builders typically require about 10 to 15% more capital cost to make a building a passive house standard. But once you're an experienced builder, this cost can drop to as low as 5, or in some cases even 3.5%. So it's a relatively small incremental cost with a very high impact. Energy savings, of course, are not the only benefits of green buildings, and many green buildings, of course, have very good lighting because they have typically large south-facing windows. And the benefit from lighting is that we tend to actually perform better. So in one study in North Carolina found that the students who were in a sunlit building, as opposed to building a room that has only artificial lighting, they did 14% better in their grades over the course of the year. And during high-stress situations, for example, during an exam, the performance actually was 21% better, so even better than during normal operations. Excuse me. Another interesting technology is using parabolic mirrors and optical fibers to deliver free lighting into your building. This is a model that was designed by Sunlight Direct, which was an offshoot of, I think, Lawrence Berkeley Laboratory. And they're basically using a parabolic mirror. This mirror is, about maybe a meter, about 3 or 4 feet in diameter. And it basically bundles all of the light up in this dome on here, and then sends it down to about 120 optical fibers. And these optical fibers then carry this light into workspaces. And it turns out that this small mirror has enough light that it can supply about 64 workstations with adequate light. And other development, this is a Japanese version of the same design. And this is a Swedish design. And I'm talking about the lights here right now, a Swedish model. This model actually also includes a optical sensor and has dimmable CFL lights, fluorescent lights, so that you always have a constant output. And another advance in designs is that we're looking more and more at something called biomimicry, which is basically trying to imitate nature, because a lot of our industrial processes are quite destructive, as we know. We can see that especially in China, but in any country. But and if you look at, for example, spiders, they can create a substance which is silk, the spider silk, which is stronger than steel, but doesn't emit any toxic compounds, no sulfuric acid, nothing else during the production, and can be produced with dead flies. So it has a relatively low input. And we are starting to learn how we can apply nature's designs to both buildings and also industrial processes. And I'll come back to that a little bit later when I talk about municipal design. Next area, some more examples, green cars. The most efficient car still in terms of gas powered in Canada is still the Prius, and it has come down in price quite a bit. When we bought ours, it was a lot more expensive. We've been running this machine now for 360,000 kilometers. This includes both business and private travel. And we still running the original batteries, and we've had only one non-warranty repair that was a computer chip for $800. So that's a pretty good track record, I think. Other benefits of driving a hybrid car can be mate selection. She's saying, he could be the one, he drives a hybrid, but does he compost? These are some other hybrid cars that have been built, but you can't buy them at this point. This is the Eco Speedster, which has a top speed of 250 kilometers an hour. So it's fast enough to get you to work on most days. But it gets 125 miles per gallon, and that's because it's actually a diesel hybrid. So it combines the efficiency of a diesel engine with a hybrid engine. And another version is the VW 1-liter car, so-called because it can go 100 kilometers on a little bit less than a liter. So it's about 320 miles per imperial gal. And it achieves that by having a design that is more like an airplane than a car. So it has extremely slippery top and bottom surfaces. It's made of carbon fiber, very lightweight. At the time it was built, it was available in any color you liked, as long as it was black. And that's because carbon fiber is black. And it also, but you can see, it has no mirrors actually. And that's because it uses little cameras on the sides of the car and on the rear to give you information of where you are. It eliminates blind spots, and also it again makes the car slide through the slipstream of air much more efficiently. And then, of course, speaking of fairly sexy looking cars, this is the one of the versions of the Tesla. And of course, Tesla is just one, but one of the most perhaps intriguing electric cars that are coming out with a pretty good range. And a recent study by the Union of Concerned Scientists found that even in coal states, you can actually have some carbon savings from electric cars. However, the real benefit, of course, of electric cars is that you can ultimately, once you have an stronger renewable grid, you can run them off renewable energy with a basically zero carbon footprint from operations. There's still some energy it takes to make both the car and the renewable energy sources like wind and solar, but they are relatively small compared to the carbon footprint of other sources like coal. So coal gives you about 1 kilogram of CO2 per kilowatt hour. Natural gas is 200, maybe as high as 400 if you count fugitive emissions from pipelines, while renewable sources are in the 50 gram per kilowatt hour range. And of course, once your grid is renewable and you're using green energy to create green energy, or to create the infrastructure of green energy, that carbon cost could drop even further. But what's also interesting about electric cars is not just that they are great in terms of eliminating virtually all air pollution from cars. And for cities, can you imagine the city of Calgary, the city of Edmonton? You walk in the city, it's a lot more quiet because electric cars have virtually no engine noise, but also you have no carbon monoxide emissions. You have no carbon dioxide emissions, no sulfur oxides, no nitrous oxides. So it would be a vast improvement in terms of in air quality. It would be an improvement if we run it with the current grid, but even more so, of course, if we have a totally renewable grid. What's also interesting is that the storage battery in the car can actually be used. It's not generally done yet, but it can be used to send power back to the grid as well. And there are 3 utility companies in the US that are trialing this right now. And they're basically trying to answer the question, if we have this big battery capacity, how can we use it to even out our grid? And this evening out of the grid is not just a problem for renewables. It's also a problem for sources like coal and nuclear, because they basically take a very, very long time to ramp up. So you were starting with, it may take a day or so to ramp up production. So you can't really respond to changes in consumer demand. And that consumer demand, typically in Alberta, we have a lot of demand early in the morning in winter and maybe around 7 o'clock at night. In the summer, it often occurs in the early afternoon because of cooling loads. So, but the important point is that these electric cars could actually help supply the electricity back to the grid, and you would basically be trading electricity with the grid. So that's like our smartphones can tell you to the second how much you paid. You called Boston at this rate, and it was for this many seconds. For what a $400 technology, you can install that in your car, in your electric car, and you have an algorithm that then determines, based on your preferences, how much of the energy in the car do you want to sell at a given time, and how much do you want to recharge. So you could even actually make money with your car even while it's parked in your garage, which I think is a very intriguing concept. And this is called vehicle to grid, or V2G. And that's up right here. And you can see me sitting in this Tesla car. Unfortunately, it's not mine. It was in Portland, Oregon, but it was still fun for the few seconds it lasted. I want to say about the smart grid. But anyway, smart grid, in other words, is a kind of a key component of a 100% renewable grid. And finally, every year, Shell actually hosts a marathon where students are building a super efficient car. It's basically kind of like a tricycle with a sleek body and a very small engine. And these students have managed to build a design that gets 10,000 miles per gallon. So it would take you about 1 liter to get to Toronto, albeit not at a high speed. It's about top speed of 40 kilometers an hour. And the cost of driving around the globe once, if you could drive around the globe on the equator, which of course is not possible, would be about $7, which is pretty amazing. I'm going to skip this one for now. Next, I'd like to talk about integration. So basically, if you think of right now of a building, we are basically kind of lone warriors. We have our own furnace that burns mostly natural gas in Alberta, and produce some gases in the process. We use we also produce our own hot water, for example. But the problem with that is that this process is not super efficient, because the byproducts that we give off, in this case a lot of heat, is basically lost. So in the city of Stockholm in Sweden, in 1990, the city had an area, a fairly large area, that used to be an industrial site, and they decided to make that into a residential area. So first they had to remove about 100,000 tons of mildly toxic waste. And then the city basically decided anybody who wants to build in this site, which is called Hammarby Sjöstad, has to meet very high performance standards for the environment. And they said 50% reduction in any impact. So 50% less energy, 50% less water, 50% less VOCs, volatile organic compounds, given off by paint from the buildings. And the key to achieving this was integration. This target sounds pretty good, but they're saying they could actually do a lot more today, because this is now already 25 years ago when they started this process. And what they did is they basically integrated. This is the slide showing how tall the Swedes are. So actually, the Swedes are not the tallest people in the world, but the Dutch, they are even taller. Anyway, back to the Hammarby model, you can see that, for example, we will take we'll take a building that gives off sewage. Now, every house, of course, has a sewage stack, and that leads to the municipal waste system. And it basically pollutes our rivers with a lot of nutrients and excessive nutrients and all kinds of other compounds. So what they did in Hammarby Sjöstad, they said, okay, how can we use this wastewater and not have it go to waste? So the first thing they did is they're extracting the heat from the wastewater using a heat pump. And interesting thing is, actually a large portion of heating in Sweden is through a district heating system, similar to the one that is proposed right now with the city of Edmonton for the Blatchford project in downtown, the former municipal airport, that is supposed to house about 30,000 people in the future. So the advantage of a district heating system is that you can basically use any kind of heat source and share it among all the buildings in the district. So in fact, some companies in Sweden, they will come to you and say, okay, I will offer you a contract for the next 20 years, whereby we will supply energy to you at 20% below the cost you're paying for natural gas right now. And in exchange, first thing they might do is actually upgrade your home, because any savings now that they're guaranteed your stable temperature of 21 degrees Celsius, any savings will go back to them, so that it's actually profitable for them to increase your house performance. And then once you reduce your consumption, they can actually use that extra heat to heat more buildings in other areas. So in Hammarby Sjöstad, they're extracting this heat with a heat pump from the wastewater of your house. But another interesting thing is that actually commercial buildings, even often in the shoulder season, sometimes even in winter, need to have cooling requirements because of the many computers in the building and the lights and a lot of people being in the building, and of course the lower surface area relative to the total volume. So what that means is you can actually you also need cooling. So this wastewater, once it has been cooled down, they can use the same cool down wastewater and use it to cool those commercial buildings. Or in turn, during the summertime, if you have heat that comes out of the commercial buildings, you can use that to create domestic hot water for residential buildings. And that's kind of integration that we think is going to happen in Blatchford, and I'm very excited about that, because I think the city has a great plan, and so far as I can tell, they're moving forward with a good plan that I think will have a very positive impact. Oh yeah, then the next step in Hammarby Sjöstad is they use the liquid waste and they run it through a methane digester, and they can actually extract a lot of methane, which is essentially natural gas, or very similar. It's CH4, and they can use this natural gas to run their bus fleet. You could also use it actually to cook, theoretically, and that's about 800 kilowatt hours per home. So in other words, our waste, our human waste, is enough energy to supply about 10% or more of your total electrical needs, or your total energy needs. No, not total energy needs, or total electrical needs. And so which is quite substantial. And then finally, the fourth step in this process is they take all the remaining solid components and they compost them, and they use this compost to grow plants in the area and basically biofuel, and they create biofuel from this, and they burn this biofuel in the biofuel plant. Now, a typical power plant like in Genesee might give you a 30 or 40% efficiency because most of the energy is lost as heat. But in this case, you actually use more like 80 to 90% of the heat because of the energy input, because you can actually use that heat to, again, heat other homes. So you're doubling, almost tripling the efficiency of your system. So not only do you get now green electricity, but you also get a green source of heating at the same time. So rather than having a power plant that burns natural gas or coal at a low efficiency of, let's say, 30 to 40%, though there are some more efficient plants coming out, and then you have your furnace where most homes burn at the efficiency of maybe 70 to 80%, you now combine these and you have a single source that basically supplies both the heat and the hot water and the heating energy at a much higher efficiency. And they basically applied this model to the whole system. They basically said, let's take any of the waste streams and turn them into a feedstock for the next step in the industrial process or in the integrated municipal process. And this is the total, all the total flows. Another example that you might have heard in the context of Blatchford is they actually have a vacuum system underground that collects all the different waste streams, and the computer basically sorts it or designates which of these bins is emptying out, and it transports the waste at 70 kilometers an hour underground. Basically eliminated the need to have smelly and noisy trucks come around and collect the waste. So what was the cost of this system? There's actually zero cost for the city itself. These are the development standards for this development, and if you don't meet them, then you cannot build here. It turns out that the incremental cost of implementing all these changes was only about 5% of the capital cost. So it's not very high. But what was interesting is that so many people liked the concept of having an energy efficient home, of having a design that is transit oriented, where you have integration of LRT. You have all the basic needs in your neighborhood. So, for example, there's a hairstylist, there are grocery stores. Many of the basic amenities and services you want on a daily basis are in walking distance. They found that the developers could actually sell these properties for 25% more than properties in the surrounding areas that didn't have this kind of development. So it's basically a win-win-win scenario. Other examples of municipal scale technologies is, for example, the living machine concept that was made in Canada concept. The machine company actually now is located in Massachusetts, but it was originated by John Todd at that time he was an ecologist in Toronto, and it replaces high intensity chemical and energy input with a biological system for treating water. So basically, this is the sewage plant. Looks a lot more attractive than many other sewage plants. It basically has a number of stages. It has a biological, has a bacterial tank, an algal tank, and then has a polishing tank that uses vascular plants. And actually, this system is running right now west of Edmonton and near Drayton Valley. The municipality is actually using this technology to clean water in the community there. And one of the summaries for this technology is basically that the system is mechanically simple, but biologically very complex. And it turns out that one of the systems they ran in the US, where there was an oil spill, and they had both the municipal system and the smaller system in a commercial application, and they found that the biological system recovered from an oil spill in about 3 weeks, while it took the municipal system about 3 months to be up and running again. So it was fairly resilient, actually, to perturbation. And they've also, in China, many of the high rises in China have no sewage treatment, and the water basically goes straight into a canal, and that is the picture here of the sewage treatment. And they planted in one area 12 kilometers of these beautiful vascular plant systems that are now basically absorbing nutrients from the waste stream and creating a much greener canal, and also a much more beautiful canal. Here's another example how innovative thinking can make a real difference in municipal planning. One, of course, the issues is stormwater. A large part of the costs of the city arise from stormwater drainage. And in this concrete design, you have a slightly depressed area for the planted areas. And you can see, it might be a little bit hard to see on your screen, but you can see those gaps in the curb here. And they allow the water to flow into this slightly lowered concave area where the plants are. So now you have two benefits. For one, you don't have to water as often, or never. And also you have less stormwater overflow. I mean, Edmonton and Calgary, every year they experience overflows of stormwater, which not really good for the sewage system. And in this case, you avoid that, and you also have lower costs for keeping the plant alive. So again, it's a win-win. It just takes a very small design change. Plant areas tend to be elevated, so they actually get less water rather than more water, as in this case. And another success story for municipal design, in this case also, was in the city of Hasselt in Belgium, or still is actually. So about 15 years ago, the city was close to bankruptcy, didn't have a lot of money, and they also had, as many countries experience, the increasing congestion of traffic. In fact, the engineers for the planning department recommended several billion euros for a new ring road that would reduce the traffic congestion. The mayor at the time took a very innovative approach to solving this traffic problem, and he said, well, let's provide bus service for free instead. The bus cost was not that high, so it's not quite as high as in Edmonton, so it was a lot easier to implement, and also a lot of the funding for the bus system comes from the federal government, actually, in Belgium. At any rate, what they found was that on the very first day of having the free bus system in the city, they increased the ridership by more than 700% to 883%. And in fact, now 11 years after the implementation, it has increased by more than tenfold. And what they found was that a lot of people actually liked this so much that it has become a shopping destination for many people throughout the region. And they had to add a lot of hotel beds to accommodate this inflow of tourists who loved the fact that they could just come to a hotel and go around shopping and don't have to worry about parking your car. They also offer actually free parking outside the area. How are we doing for time, Ted? Are we doing? Okay, thank you very much. Okay, I will maybe speed it up a little bit. We're working also on a zero carbon sustainable community in the Edmonton area. Let's get just a few more points about where Alberta is heading. So right now, this is a graph that shows the recent carbon emissions from electricity, a lot of coal. So Buses has joined a group called the Alberta Green Economy Network. And this network is basically trying to provide advice for the Alberta government on how we can an economy that jobs and also reduce our carbon emissions. And one of the proposals we have is a energy efficiency fund of $5 billion. Yeah, and that's billion as with a B, not million, which would be funded out of a carbon pricing, a carbon tax. Actually, would only need a small portion of that carbon tax. And this step alone could create about 46,000 permanent jobs in Alberta. And that is because retrofits have a fairly labor intensive, and you get about you get around 40 jobs per $1 million invested. So it's a lot more than in some other areas of the economy. The next proposal is that we want to see a renewable grid of 20% renewables by 2020, including 800 megawatts of solar. We are asking for a coal phase out, and of course that is already a election platform of the current government, because coal actually gives off as much CO2 in Alberta as all of the oil sands, at least in the production phase. So it's quite significant, and coal is definitely the most polluting source of energy that we have on the planet right now. And the health impacts of this alone are about $300 million in reduced health costs for Albertans and 100 deaths averted every year. We're also asking for carbon pricing. Our proposal is $50 per ton by 2017, and that would apply not just to the large emitters, as is currently the case, but to basically the whole economy. And that would result in about $11 billion in revenue. And you just need about 8% of that for the efficiency program, and about another additional 3% for incentives for renewables to achieve both of those targets. And if you look at the fiscal framework for this, you can see that we can raise about 46,000 permanent jobs for energy efficiency this way. Renewable energy, the given target would create an additional 8,600 jobs for renewable jobs. So a very, very significant source of jobs. And it would be financed basically by those who create pollution in Alberta, which includes both industrial emitters, but also ourselves. So we're basically helping ourselves create green jobs. And if you look at the carbon impact, so the orange graph here shows you the increase in greenhouse emissions in Alberta. The United Nations say we have to cut these emissions based on 1990 levels by 20 to 40%, which is the yellow and the green curve. The government of Canada, the previous one, has committed to cutting our emissions by 17% based on 2005 levels over here. So this is basically the government of Canada. Our proposal only achieve 1/3 of the target that the other Canadian government has targeted, and that may surprise you since we are a green organization. But because we have increased emissions so radically in Alberta over the last decades, it is very hard to turn that around. But even if you achieve a modest goal, we can turn around Canada, because right now it's basically Alberta is responsible for the majority of the growth in emissions. And some other provinces like Ontario that has a coal phase out already a while ago, they have already reversed the trend quite strongly. But if we can reverse Alberta, we can actually reverse all of Canada. So it would be a great achievement. And one of the positive things about solar energy is when there's a huge solar energy spill, it's just called a nice day. Thank you very much. That was my presentation. This is an advance notice of the next presentation coming up in the webinar series. And now I'll be happy to go to the question section.
So for participants, you should be able to hover and find the Q&A function, and you can pose questions to Godo. So we're open for questions. So I guess while we wait and while people kind of think, Godo, it's a good opportunity for you to continue in your response or advice to, I mean, this whole Greening Government Speaker Series is about what should government do. So what kind of overall things would you suggest?
It's a very good question. And I've mentioned, of course, already some that is a incentive program for efficiency and more renewables, coal phase out and carbon pricing. But I think there are many things that can be done within government as well. I mean, right now, really the performance standard for buildings is net zero or passive house or something in that area, something that has a significant reduction in efficiency in energy consumption. So I think if the government said all new buildings should meet that standard, that would set a great example. And we can see, for example, the Equilibrium program that created the first net zero homes in Canada had a very small cost, but it had a major impact on the building industry, because you need to get people thinking about this, and you need to get the building industry, you need to build capacity essentially for people who actually know how to do that, because it doesn't happen overnight. You know, if people are built in a certain way in houses, the building industry is very, very slow changing, and you need basically an incentive to say, okay, let's build it, and once you know how it's done, it becomes a lot easier the next time.
No, that's excellent, Godo. There's been a question posed. Do you have examples of residential design on the west coast of Canada for energy and solar, etc.?
There are many examples. It's actually a lot easier to implement this design on the west coast because the temperatures are not quite as cold, as we know. So there is Drake's Landing, for example, that had a very high LEED rating. Design that's in Vancouver, and I've seen many other examples of earth homes, or a whole range of buildings. So Drake's Landing is all I can think of right now as a specific one that you can look up on the internet, but there are definitely many.
Well, there's another question or comment that's come in about the new Tesla battery to support star energy. They look cool and sleek and appear to solve the problem, battery banks, etc. What's your take on the Tesla battery?
Right. Okay. I didn't get all of your question. Do you want to repeat the second half?
Oh, certainly. Okay. So do you have any insights or comments on the new Tesla battery to support star energy? They look cool and sleek and appear to solve the problem of battery banks.
Yeah, so I'm definitely very excited about the product. I think it's a really good price, very good, probably the industry best warranty of 12 years. So I think it's a good solution. Most Alberta homes that are so choose to stay on the grid because you can trade your energy, and energy storage is still relatively priced. It is coming down, and important component of future grids that allow us to respond very quickly to changes in demand and consumption. So I think I don't think everyone will have these in the near future, but I think it will definitely for off-grid. This is already fantastic, and it will play a role, I think, in moderating demand control in the grid overall.
Another question. Wonderful presentation. Are there resources or materials, presentation, PowerPoints, etc., that we can refer to or connect others to?
Good question.
Well, you got your website. I think that's an opportunity for you, Godo.
Sure. Yes, I should plug the website, carbonbusters.org, but it is not really designed for educational purposes. I mean, obviously, I've written some of the books. You can look up under my name on the web. Otherwise, yeah, I think this seminar will be online. No, yeah, the books are probably good sources. You have a lot of links. But another very good source is that oil endgame. If you want really like hard-hitting facts on efficiency and how we can move to a cleaner economy, that is a very good source, and it's free actually. Yeah.
Well, and the other thing, as you mentioned, Godo, all of the sessions are recorded, and they will be posted to YouTube, to the Municipal Climate Change Action Center. So if you just go to YouTube and you search for the Municipal Climate Change Action Center, you'll find it, and all of the presentations will be listed there. Another question that's come in is, what would an average cost to retrofit an Alberta home at around, say, 1,200 square feet?
Yeah, so our average retrofit is about $5,000 for C returns. Now, some of the retrofits, some people we have done the whole house from light bulbs to solar panels or solar modules, and others are more modest. You know, they just want a better furnace or maybe insulation in the attic. So I think in the first year, I think the average retrofit, yeah, was $5,000, and they saved about 3 times that much in energy. So about $15,000 in savings over the life of the various measures.
Mhm. Well, we've got an interesting question here that you might want to ask your publisher, Godo, is, are you planning on putting out an updated version of the Home Energy Handbook? It was a very helpful resource.
Thank you very much. That's very kind. And it did sell amazingly well. It was nominally a bestseller in Canada, which is a relatively, not a very high target, unfortunately. But still, so that was really, it sold really well. But and I would love to do an update, and the publisher, I think, would welcome that. It's just I have to finish my PhD first, and it will take me probably about another 15 months because I'm waiting for the data from our zero carbon building that is just being completed. It should be completed in the next 4 weeks, and then I need about a year's worth of data, and then I have to finish my thesis. So my supervisor might get a little upset if I say, oh, by the way, I'm writing a book, can you wait another year or two?
Yeah. So in the meantime, with you being pretty busy with your PhD and paying the mortgage, Godo, we're pretty lucky to be able to get you to present to us. Thanks so much for that. So it looks like we got another one, another comment here, Godo, that you should be hosting Zoom sessions for homeowners with your resources as references. So a plug for and another comment here is, I heard that Nissan is already implementing energy storage using the Nissan's Leafs in Japan, specifically for emergencies, earthquakes. Do you see vehicles and energy storage as an option for government? Pretty interesting idea.
No, I think it's a very good question. And I think Better Place was a company that used to try to implement a electric charging system, perhaps a little bit before its time. And they said that, for example, in Denmark, if 1 million people had electric cars, that electric capacity would be 5 times the capacity of the total grid. So obviously not for unlimited time, but yeah, I think that it's a very good concept, and I think we definitely need to move that way. We need to have both a smart grid that basically allows to go both ways. We need smart meters that will basically credit you with what you're providing to the grid. And we need a time of use or dynamic pricing so that your car can say, hey, right now I can sell this for $1 a kilowatt hour, so why wouldn't I do that right now and make some extra money on the side and help the grid overall? So I think, yeah, that's a very good suggestion.
Well, I guess one question that I would pose, Godo, and I think it's really a review question, is what was the URL or the address for that green consortium that you're involved with?
Right. I think it's albertagen.ca.
Ah, wonderful. Thanks. There's another question.
Type in, yeah, Alberta Green Economy Network. You should also find that.
Excellent. Another question is, with respect to 46,000 retrofit positions that could be created, does the GOA have a link to the training program that might supply these?
No, this was basically, we were doing the policy paper, and we were simply trying to find out what are the policies that we need, how much do they cost, and how many jobs should they create, and how much carbon do they reduce. So this is a number from the Canadian Energy and Mines and Mining Ministers. There was basically a study done for the government of Canada, and it simply looked at the cost. But we have training programs. For example, at NATE, there's an excellent alternative technology program, and I'm seeing more and more of the people. I'm on the advisory board or Shantu is on the advisory board for that organization, and they have an excellent program, and more of the people I see now in the green businesses come out of that program. So that'll be one example. And SATA is also a very hands-on program in Calgary. So I think that's examples of excellent programs that already exist.
Well, another pretty tough question has come in, Godo, and have you done any analysis of how the government of Alberta could use your carbon busting research to leverage the cap and trade system on CO2 emissions, for example, GOA, efficient building, staff telecommuting, etc.?
Yeah, so basically this energy policy that we created, I did play a role in creating that efficiency proposal, and that has a lot of detailed recommendations of what the Alberta government could do to bring this about. And we are actually kind of mildly more in favor of an actual price on carbon, because it is a bit more certain of the outcome, because you can't game the system. You know, one of the issues, even though I think cap and trade can be very effective, if you put too many credits into the system, then you'd have not very much impact. That's what happened in Europe. So yeah, I mean, it doesn't really matter whether it's carbon pricing or carbon trade. Yeah, I mean, carbon trade, I can see what you mean. I think I see what the question is aiming at. That would be easier with a trade system, but it has also its disadvantages. So I would have to think about this more.
Well, this is, oh, we got another one. Where do you find your energy policy recommendations, Godo?
Well, we made them up, right? We didn't find them, but there's many.
No, just many... where can people find them? If they Google, what search terms should they use?
Very good. So you go to the albertagen.ca, so albertagen.ca, and there's a link there actually to all the recommendations we made. It was assembled in a very well over the summer. It took us a few. Let me see if I can get out of this.
Yep.
Yeah, actually I can't get out right now, but oh, here we go. Let's see if I can call it up. So here's the website. And it will eventually load as well. And there's a link to basically all the policy organizations. There we go. So this is where the submissions are. So under albertagen.ca/other-resources/, and this is that's the submission. So I'll give you some of the details, and it is fairly well referenced. I mean, it was a very short time frame that we had to create this to meet the deadline of the climate change panel, but I think it's a good document.
Oh, excellent. Well, I'll just open it up. One last call for questions before we conclude your presentation, Godo. Just we'll give a few moments if there's any other questions. Well, okay.
All good.
Well, it's pretty cool that we're able to do this from our desktops, Godo, and convenience. No carbon generated with this speaker series, and it's wonderful that you could join us and present. And so just thrilled that you could make the time to present. And
that's right.
I know you'd enjoy Dr. Yvette Blount, who will be presenting this Thursday evening at 7 p.m. and you had the screen there with the information on that presentation. So it's going to be quite interesting. And
that's right.
In our testing with the technology so far, with low bandwidth connections, it's been working just fine. And yes, here it is in terms of the description: telework, boot the commute. And you can see, for people viewing, you can see the link and the webinar ID. So we'll just give you a few moments to, if you're interested in that this Thursday evening, write that down, and I hope you'll join us. And with that said, Godo, thanks again so much for participating and presenting. Fascinating, wonderful work. And so what do you figure? A couple more years and we can call you Dr. Godo or not?
Absolutely.
Absolutely. Wonderful.
Sure.
And we'll look forward to that third generation carbon buster as well, your son.
Thank you. That's right.
Excellent. Well, thanks so much, Godo.
Thanks.
Okay.
Bye-bye.
Take care.